Before the start of production, the materials are made available. Plates and profiles, mostly made of high-tensile HY80 steel, are supplied by a Thyssen company from the Ruhr area and stored in the plate and profile store. Before their use, all plates and profiles must be shot blasted, primed, and marked. After arrival in the flame cutting hall, the plates are marked and cut by numerically controlled flame cutting machines. Then the welding joints are prepared, holes, cutouts, and shaping cuts are made true to gauge. The pressure hull plates are pre-shaped by hydraulic presses and then cold rolled to measure on a bending roll. Elsewhere, the frames are put together. A frame consists of several flange and web plate segments which are welded together. The flanges are rolled from flat steel. The webs are flame cut from plates. For the assembly of the frame, the segments are placed into a tack and assembly jig and tack welded. Mounting of the restraining elements to the first annular frame. Compasses are used to check the circularity. The seam is prepared. Then web plate and flange are welded together. This kind of work requires particularly experienced, specially trained welders. Several frames and the corresponding pressure hull plates form a subsection. The treatment of the pressure hull plates and the fabrication of the frames are followed by the fabrication of the subsections, a highly complex part of the production. The pressure hull plates are aligned, tack welded, and preheated. Now follows the welding of the seams. The root layer is ground and all the welds are inspected with testing equipment. Several subsections form a section, in which also parts of other structures are incorporated. The restraining devices and the staging have to be removed. The components are placed on slewing mechanisms, enabling them to be turned into an optimal working position. Walls, decks, bulkheads and tanks, as well as the supports for engines and aggregates, are assembled individually and incorporated into the section. The battery compartments are assembled to form large boxes and then fitted into the section in blocks. installation of cable and pipe supports, special automatic welding machines are used. The pressure-resistant transverse bulkhead is also built separately and then fitted into the section. Manufacture and assembly of this bulkhead are extremely complicated. The transverse bulkhead serves to divide the submarine into two watertight compartments. Special care has to be taken when drilling holes for the lead-through of cables and pipes. All materials and processes are tested in the testing laboratory. To prove the tensile strength of welded connections, sample pieces are subjected to tests that go far beyond their expected yield values. For the manufacture of the pressure-resistant parts, such as the pressure hull, bulkhead, access shaft, and torpedo hatch, preference is given to steel with high tensile strength and notch toughness. One example is the heat-treatable HY80 steel, developed especially for the manufacture of submarines. In the presence of the Commander-in-Chief of the Argentinian Navy, the keel laying of the first section of the TR-1700 prototype was celebrated in a short ceremony at the Thyssen shipyard. Now begins the actual assembly of the submarine. All the sections together finally form the pressure hull. The sections are assembled in a hall for which special security measures have been adopted. This is also where the pressure-resistant reinforced access shaft is built. The bow section of the boat is equipped with the torpedo tubes. Part of this section is a spherical bulkhead, the forward ceiling of the pressure hull. This bulkhead is penetrated by the 6 torpedo tubes, arranged in 2 rows, one above the other. Sealed with heavy, forged covers, they will later house the torpedoes, ready to be fired. While the submarine is underway, this forward section is flooded with water. The assembly of the course-keeping and depth-keeping rudders is a complex process and requires specific templates. For the pressure hull penetrations, special reinforcements are made and welded into position. On slewing mechanisms, each section can be brought into an optimal position for the boring of the penetrations. A transportable boring machine is accurately aligned and then carefully starts taking off chip after chip. For the passive sonar systems, windows are milled into the sidewall steel plating and later covered with fiberglass reinforced plastic plates. The noise level of a submarine has to be kept as low as possible. For this purpose, engines and generators are supported by special foundations of layered steel and rubber elements. These elements act also as effective shock absorbers. Prior to the installation of the engines in the engine room, the elastic elements are carefully fitted into their exact positions. The diesel generator groups are installed with the aid of a crane and special supporting structures. Connections in the seawater exposed sections of the submarine are made of copper-nickel alloys, which have proved to be resistant to both seawater and wear and tear. All sections are sandblasted and coated with primer. A heavy-duty lifting truck transports the aft section of the submarine from the sandblasting hall to the assembly hall. During the entire building period, all the components are securely and safely stored on supporting and transport foundations. Knowing the exact weight of the submarine is extremely important for the hydromechanical calculations. In order to match the design values, each individual section has to be weighed. This is accomplished by 4 electromechanical pressure cells. Any component which is installed later also has to be weighed exactly. Meanwhile, all individual sections have arrived in the assembly hall. While the outfitting and installation work is progressing at a lively pace, the welders are joining the first connecting seams.